Alright, problem 1, we're supposed to find the exact value of sine of 15. It'll be sine, cosine, or tangent of some angle that can be created with the special angles we've got on our sheet. And in this case, 15 degrees, 45 minus 30 would make 15 degrees. We know the sine, cosine, tangent, all that of 45 and 30 exact numbers. So that'd be the first goal. It's going to be some angle like that, 75, 105, 165, something will be in the 15 degrees off of one of them. So it's not that hard to create a subtraction or addition to make that. Suppose it was 105, 60 plus 45 would work. 135 minus 30 would work. So, I mean, there's different ways to make them. 45 minus 30 works in this case. Once I get the sine of 45 minus 30, useful trig identity sheet number 32 is the sine of a sum or difference. It tells me I take sine of first, cosine of second, same operation, minus in this case, and then cosine of the first, sine of the second. And then looking on your sheet, or just from memory, sine of 45 is the square root of 2 over 2. Cosine of 30 is the square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Sine of 30 is 1/2. This is going to be the square root of 6 over 4, and that's going to be the square root of 2 over 4. Both over 4, so we can just make one simple fraction out of it. Square root of 6 minus the square root of 2 all over 4. I'm looking for an answer something like that. It's usually along those lines with sine or cosine. If it were tangent, it might be a little bit different than that. But again, tangent has its rules, so just apply the rules that way. Number 2, we got two angles, alpha and beta. Alpha's in quadrant 3, so if I draw a quadrant 3 right here, draw alpha into quadrant 3, always draw the vector from the origin out into the right quadrant and then go up to the x-axis to create the angle. Create a right triangle. Sine of alpha, so opposite over hypotenuse, negative 5/13. The negative goes on the up and down, the 13, the hypotenuse is always positive. A Pythagorean triple, 5, 12, 13. And since I'm going left for this dimension, it's a negative 12. That gives me a sine of alpha, of course, is negative 5/13, what they gave me, but now I know cosine of alpha is also negative 12/13. So all that right there created this right here. The other information I've given as beta is living in quadrant 2, and cosine of beta is negative 4/5. So if I draw a quadrant 2, put a vector out into quadrant 2, draw my angle from the vector to the x-axis, there's angle beta. The cosine is negative 4/5, so adjacent over hypotenuse. The adjacent side is negative, the hypotenuse is positive. Hypotenuse is always positive. 3, 4, 5, Pythagorean triple. This dimension is going up, so it's a positive 3, negative 4, positive 5. That tells me the sine of beta is positive 3/5. The cosine of beta, of course, is negative 4/5, which was given to me. So at this point, I know the sine and cosine of both angles, and I'm supposed to find the sine of alpha plus beta. Those are my directions. Sine of alpha plus beta, but from number 32 again, is sine of alpha, cosine of beta. Same operation, cosine of alpha, sine of beta. Once again, I know the sine of alpha, the cosine of alpha from over there, cosine and sine of beta from over here, so it's just a matter of putting those in there. So sine of alpha is negative 5/13. Cosine of alpha is negative 12/13. Cosine of beta is positive. There should be negative 4/5. So negative 4/5. Sine of beta is positive 3/5. And these are being added together. So then if I just work it out, negative 5 and negative 4 make positive 20 over 65. Even though reduction is possible, don't ever reduce because you get a common denominator on these if you don't. Negative 12 plus, or times 3 is negative 36. And 20 minus 36 makes negative 16 over 65. I I did not find tangent because I knew that this didn't require me to find tangent, but if I did need tangent, positive 5/12, negative 3/4, I could find tangent also, but it was sufficient to find sine and cosine. It's going to be given information like this. Make sure you draw the angle in the correct quadrant. It won't necessarily be quadrants 3 and 2. It could be sine or cosine. I'll probably stick to sine or cosine there. So just use the proper identity in that problem. Number 3, write cosine of 8x, cosine of 4x plus sine of 8x times sine of 4x in terms of a single trigonometric function. Got my useful trig sheet here just so we can look at it. What we're trying to do is compare that to one of these structures. And if you look at 33, cosine of 2 angles minus or plus sine of 2 angles, that's what's going on in our problem. Cosine of 2 angles plus sine of 2 angles. So that's just cosine of a sum identity. And we're going from the left hand to the right hand side. So if I write that identity down, cosine of x plus or minus y is cosine of x cosine of y minus plus sine of x sine of y. This is that side. And it's got a plus sign, so that means in this one you get a minus sign. So it's going to be cosine of something minus something. And the x and the y are the first and the second thing. So there's x, there's y. So 8x goes here, 4x goes here. 8x minus 4x is 4x. Okay, what I can tell you about this problem on the test itself, I'll probably stick to this area of the sheet. I'm going to give you one of these structures probably, and you'll just have to go back to one of the other structures. So just make a notation of how x is related to the angle. So x here, you double it. X in here, you half it. If you have cosine, cosine, sine, sine, you add them or subtract them. Sine, cosine, cosine, sine, you add or subtract with sine. You know, it's just a matter of matching the structure and then going back to one of those simpler expressions. Number 4, find the exact value of cosine of 2 theta given sine of theta is 8/17 and theta is in quadrant 2. So quadrant 2, once again draw it in the right quadrant. There's theta. Always draw from the vector to the x-axis for the angle and straight to the x-axis with the right angle for the remainder of the right triangle. Sine is opposite over hypotenuse, so 8/17. Once again, Pythagorean Triple, 8, 15, 17. Since we're going left here, that's a negative 15. So I can see very clearly the sine of theta is equal to 8/17, as we already knew. Cosine of theta is going to be negative 15/17. And our cosine of a double angle formula is, I'm going to go with the cosine squared minus sine squared version. So cosine squared is going to be this squared, so it's going to be 225 289ths. It's positive because squaring anything you get a positive even though the cosine is negative. Sine squared, if I square this, I'm going to get 64 over 289. Subtract those, 225 minus 64 is 161 289ths. I'm going to give you this type of information, like so, and I'm going to be asking for either sine, cosine, or tangent of 2 times the angle. Number 5, find the exact value of sine of 75 cosine 105. That's one of our newer ones on the back of the sheet. Product of sum identities. Sine, cosine of things as a product can be changed to 1 times sine of the sum plus sine of the difference of the 2 angles. It could just as easily be cosine, cosine, or sine, sine. So it's going to be one of these structures here for this problem. You have to transform to one of these structures over here. So this structure specifically, sine of an angle, cosine of an angle is 1/2 times the sine of the sum of the angles plus the sine of the difference of the angles. And x is the number with sine and y is the number with cosine. This subtraction, the order of that's important. So whatever's with sine is x, whatever's with cosine is y. Just kind of make a notation of that when you're using these identities. 75 plus 105 is 180, and 75 minus 105 is negative 30. Okay, now it says exact value, negative 30 is not one of our numbers on our sheet, positive 30 is. What you can recognize, hopefully, I don't know that we use these a lot, but our negative angle functions, so sine, tangent, cotangent, cosecant. If you have negative angle, it changes the sign. For cosine and secant, it stays the same sign. In this case, you're looking at, we have sine of a negative angle, so according to number 14, that's negative sine of 30. So it's 1/2 times that. The sine of 180 is 0, the sine of 30 is 1/2. And again, it's sine of negative 30 is the same as minus sine of positive 30, so it's minus 1/2. 0 minus 1/2 is negative 1/2, times 1/2 is negative 1/4. That's the exact value of that. Number 6, find the exact value of sine of inverse cosine of 15/17. Now this one doesn't specify quadrant. Remember that cosine lives in quadrants 1 or 2, so does secant. The other 4 live in quadrants 1 or 4. So this is inverse cosine of positive 15/17, that's quadrant 1. I'm going to call it alpha. So this inverse trig function represents an angle. That angle is going to be called alpha. Alpha has a cosine of 15/17, so adjacent over hypotenuse. Now this angle has a cosine of 15/17, that's how you draw alpha. 8, 15, 17, a Pythagorean triple. I'm going to stick Pythagorean triples here, so 20, 21, 29, 3, 4, 5, 5, 12, 13, those. If you don't remember them, then you can always use the Pythagorean theorem, but remembering the triple will save you some time. But it's going up, so it's positive, going right, positive, hypotenuse positive, so first quadrant everything's positive. This problem becomes sine of alpha because cosine inverse 15/17 is alpha. So change that to alpha. Alpha is this, and sine of that is 8/17. So basically, use this to draw the triangle, then find the correct trig function based on that. I would put any trig function here, any trig function there. I don't think there's any concern there. I'll probably stick to a positive angle, so it'll be a first quadrant thing, but if it said inverse tangent, inverse secant, inverse whatever, you should be able to draw the triangle from that, and then you should be able to find the correct trig function from that. So I would stick any trig functions in that problem with no problem, without any concern. Number 7, solve sine of 5 sine of x minus 2 equals 0. We want answers between 0 and 360. Now this is sine. I could go with cosine or tangent. I'll probably stick to sine, cosine, or tangent in this one. Remember your rules for finding all the answers. So for sine, first of all, if I solve it, it's going to be 5 sine of x equals 2. So sine of x is equal to 0.4, which means x is going to be the inverse sine of 0.4. Okay, our calculator's programmed to find the answer in the first or fourth quadrant for inverse sine. In this case, it's the first quadrant, so if I do inverse sine of 0.4, I get 23.57817848. It says round to the nearest tenth, so 23.6 degrees. In sine, to find the other answer, you always do, the other answer is going to be 180 minus the answer we just got. So it's going to be 156.4. Alright, so if it said, let's say cosine, suppose it said 5 cosine of x equals 2. Or 5 cosine of x minus 2, so of course move the 2 over. That gets me cosine of x equals 0.4. So I'm going to do x equals the inverse cosine of 0.4. So inverse cosine of 0.4 comes out to 66.42, so 66.4. For cosine, the second answer is 360 minus the first answer. So if I do 360 minus 66.4, comes out to 293.6. If you try it out, cosine 293.6, it should be 0.4. You can see that. So again, the calculator is programmed to find me the answer within that initial interval for cosine first or second quadrant between 0 and 180. You have to do the 360 minus, remember that part, to get the second answer. Had it said tangent, so 5 tangent of x equals 2. That means tangent of x equals 0.4. That means x equals the inverse tangent of 0.4. So I do inverse tangent 0.4. Comes out to 21.8 degrees. The second answer for tangent is 180 plus the first answer. So the second answer is going to be 201.8 degrees. So again, it's going to be sine, cosine, or tangent. If I try it out here, tangent of 201.8 comes out to 0.4. All right, so just again, obviously know how to do this much. It'll be a basic one like this. Won't be very difficult to get the first answer. Just know what to do to get the second answer. 180 minus, 360 minus, 180 plus for each of the 3 trig functions that could happen on that problem. Number 8. 2 sine of x cosine of x minus cosine of x equals 0. They want the answer between 0 and 2 pi. This one is just a basic factoring one. We got cosine in both expressions, so if I take a cosine of x out, I've got 2 sine of x minus 1 left. And that just means that cosine of x equals 0 or 2 sine of x minus 1 equals 0. I move the 1 to the other side to make it positive, divide by 2, so sine of x equals 1/2. 0 and 1/2 are our magical numbers that have exact answers, so we have the ability on the interval from 0 to 2 pi to find all of our answers. So cosine equals 0 at pi over 2, and again at 3 pi over 2. Sine equals 1/2 at pi over 6, and again at 5 pi over 6. So x equals those 4 numbers. I will stick to the sheet that has all the values on it. So if it was a tangent, it should be either square root of 3, square root of 3 over 3, 1, or 0. If it's cotangent, same. If it's secant, 2 times the square root of 3 over 3, square root of 2, and 1. Otherwise, so it'll be one of those. But I'll probably stick to sine and cosine, to be honest. But just know your magic numbers there so that you recognize that they'll be on the sheet. I want the exact answers when possible on these problems. Number 9, find the exact solutions of this. Now, what I want you to notice about this one is this sine of 2x here, and everything else is x. Cosine of x, sine of x. It's very important in these problems that you have all the angles the same type of angle. So I have a double angle formula for sine of x. The first thing I would do there is I would immediately change this to 2 sine of x cosine of x. Okay, the rest of the problem is fine with x's because these now have x's, so plus cosine of x plus 2 sine of x plus 1 equals 0. So at this point, I'm looking at a 4-term polynomial. I always look for factoring first. If I'm factoring a 4-term polynomial, I'm going to group and group. This is a plus, which is good. No sign changes required. Common factor cosine of x here. That leaves with 2 sine of x plus 1. There is no common factor here, so I'm going to put a plus 1 times 2 sine of x plus 1. So 1's a common factor, and then it just keeps the parentheses the same. And with factor by grouping, if these groups are the same, then you're good to go. So 2 sine of x plus 1 times cosine of x plus 1 equals 0. Once again, I get factored form. This gives me 2 sine of x equals negative 1 divided by 2. So sine of x is negative 1/2. This was going to give me cosine of x equals negative 1. In both cases, equals 0. Move the 1 over, changes the sign. So once again, negative 1/2, negative 1. These are numbers on our sheets. So we're looking for answers between 0 and 2 pi. Cosine's negative 1 at positive pi, and sine's negative 1/2 at 7 pi over 6, and again at 11 pi over 6. You will have the sheet available to you during the test, so just again, recognize the numbers and give me the correct angles. I don't want answers between 0 and 2 pi. On some homework back a while back, some people gave me like an answer like this that would have given me pi and negative pi. I only want the positive pi, so answer between 0 and 2 pi, that's all I want. I would probably deduct a point if you gave me extra answers outside that interval. Number 10 and 11 and 12 were all verification of identities. I'll say for the identities on the test, similar techniques will be used for the identities on the test. So this one's going to be all about substitution with the sum of difference identities, so expect that to happen. I have a choice of starting on this side, doesn't matter which side I start on. I'm going to start on the left. It looks to me like I can do more stuff with the left-hand side. I recognize cosine, sine is the cosine of a sum or difference, number 33. So if I start there, cosine of x, cosine of 3x, minus sine of x, sine of 3x. The first step in these identities, always write down the side you're going to work with. Don't just start writing underneath there. Actually write the side you're going to work with and identify it left-hand or right-hand side. Cosine, cosine, sine, that's cosine of a sum or difference. I changed the sign, so plus x and 3x are the numbers, which just gets me cosine of 4x. Again, that's number 33, and this is just simplification. You can write x plus 3x equals 4x if you want to. At this point, I'm trying to create this structure, cosine squared minus sine squared. That's just cosine of 2 times 2x, and that is 2 times 2x. So the next thing I would do is write this is 2 times 2x, which is the fact that 2 times 2x is the same as 4x. Again, if you do something basic like that, if you just write the fact that's true over there, that'll be sufficient for a reason. Cosine of 2 times an angle is cosine squared of the angle minus sine squared of the angle. And that's by number 36, I believe. And that's what side we're looking for, so basically expect some sort of simplification maybe, and then some substitutions in the sum of difference identities and the double angle identities. Maybe the half angle identities will show up, but the whole idea here is you're going to stay in that 32 through 40 range. Simplifications and substitutions, that type of stuff will happen in the problem like number 10. Number 11, I'm noticing the right-hand side is a little bit more creative than the left-hand side, so I'm going to take the right-hand side here. Right, again, first step is to write down that side, so cotangent helps to write down the right thing. Cotangent of x plus tangent of x over secant of x. That's right-hand side. Again, that's the first step, and some of you on the last quiz and some of your homework problems, you didn't write the first step down. You just started writing underneath it. So I want you to actually write down the side you want to work with, identify what side it is. Cotangent, tangent, secant, they're all able to be written in terms of cosine and sine. So cotangent is cosine over sine, number 2. Tangent, sine over cosine, that's number 1. Secant's 1 over cosine, that's number 3. Next, if I multiply everything times sine cosine times this, the sines cancel, I get cosine, which is cosine squared. Cosines cancel, sine is sine squared. Cosines cancel, I get sine. So again, all I did was multiply top and bottom by sine of x, cosine of x. So multiply top and bottom by the same thing. Okay, at this point, cosine squared plus sine squared is equal to 1. That's number 5. And 1 over sine is cosecant. That's number 4. Okay, so a Pythagorean identity happened, some 1, 2, 3, and 4 happened. So expect that some substitutions with 1, 2, 3, and 4, maybe multiplication of top and bottom by the same thing to simplify, and then probably some Pythagorean identity will be sticking around. So those types of techniques will be necessary for number 11. For number 12, you can see here very clearly, sine of x plus y, sine of x minus y, that's just number 32. We got sine of a difference, cosine of a, or sine of a sum, sine of a difference. I'm going to take the left-hand side here. So again, my first step, write the left-hand side down as is without changing it. Identify it for what it is. And then apply identity. So number 32 says sine of a sum is sine of x cosine of y plus cosine of x sine of y. Sine of x minus y is going to be, let me do these in different colors, so this one here is going to be plus sine of x cosine of y minus cosine of x sine of y. Both of those are number 32. both sine of a difference, sine of a sum. Okay, those are the identities. Next, if I simplify, cosine of x sine of y minus cosine of x sine of y cancels, and sine of x cosine of y plus sine of x cosine of y is 2 sine of x cosine of y, and that's just by simplifying. That's the right hand side. So I'll probably stick to the double angle identities, the sum of difference identities there, do some simplification. So one of those identities happens, and then just the projector shuts off. So I'll call that the end.